So, hello, it's me again. In this presentation, I would like to talk about FAIR principles a bit. Probably heard a lot about them. I will try to do it slightly differently. And I would like to thank Ilona Trtíková, who helped me with resources for this presentation, but she didn't see the end result, so she may be scared right now and surprised and everything. So, let's hope she'll be fine with it. Okay, so it will be, have you ever heard FAIR? I guess you did. So I wanted to try to explain it in a very simplified way. FAIR is, of course, acronym. It's findable. It should be possible to find. It's accessible. The data should be clear how to access data. Data should be interoperable. They should work with other data and tools. And it should be reusable, so it should be possible to understand what the data are about and reuse them. And some more specific principles which are described in 15 points, which you won't see in this presentation. But you can find them somewhere on the internet. What I want to do is to take inspiration from How to FAIR, which is Danish page, where they just looked on several aspects that can be that are important if users want to create FAIR data. These aspects are metadata, persistent identifiers, access, data formats, licensing, and documentation. And I want to do is to talk a bit about them and show some examples how different repositories implement these features or how they work with them, and then ask a question, who is actually responsible or who should do what to enable repositories to be filled with beautiful, FAIR data. So let's start with metadata. It's the easiest way how to say it is that metadata are data describing other data. It may mean some structure. You need to determine which field you want to use to describe data. For example, you want some title in schema of Dublin Core, and there may be some rules what to fill them with. For example, the title can be FAIR principles in NRP repos, which is accidentally the name of this presentation. If you are creating some metadata, you can go generally in two directions. You can allow the users to use custom keywords, or you can go through some, you can select the keywords for them in some extension if you do it in a more easier way. It's controlled dictionaries. If you would do it in a bit more extensive and complicated way, you can use some ontologies. What it will actually lead to, and what's better? It depends. If you want some user creativity, you can let them write whatever they want. So I used Zenodo as example. I wrote hockey stick. Okay, I can have keyword hockey stick, whatever. But if I use something like Polymer, which is kind of terra incognita to me because I'm really bad at it, I get something different. And you can see that we have suddenly many different words in parentheses. And it means that there are specific terms that are talking about polymers and that they are coming from some controlled dictionaries. It's helpful because other people will understand better what I meant, because you can find, for example, what polymers mean in MESH, which is thesaurus for medicine. And you will also use the same words as other people would. So these things are helpful. On the other hand, you can't really put information about hockey stick in the system that would just go with some control dictionaries. Another thing is that the different domains have different dictionaries, and you are limited by the specific domain. What Zenodo does in this case, they use several different dictionaries: Gemet, EOSC, MESH, or it's better to show it here because there are these three specifically mentioned that they have three controlled vocabulary terms. So Polymer is actually a pretty nice example because it's in all of them. So what's better? Do you want your users to be creative, or you want to limit them? If you are in a library, you will know the libraries describe it very strictly, so then they can organize stuff according to it. If you ask about Ostrava in the portal of Knihovny CZ, you will get these pretty nice facets. First is strojírenství, hornictví, stavební inženýrství, stavebnictví, and the numbers are reasonable also, and it will separate the content in very reasonable categories. If you want, on the other hand, use some very specific keywords, like in this case, this is metadata from one of the videos in Linda Claria, National Film Archive. This is about the funeral of František Křižík, and you can see some interesting things like kropenka, for example, or hřbitov, or hodnostáři církevní na pohřbu, which can be, of course, added as a keyword. There is also something more structured, places, Praha, Vyšehrad, kostel svatého Petra and Pavla. So there is some structure that can be used for that. It depends really what you need and what you expect from your metadata, but it's very, very interesting. Another thing is that you can structure metadata differently and you can use some domain standards for that. As you can, for sure, very nicely see, here are two examples of some specific schemas. Darwin Core, which is used in biodiversity, is one XML schema, XML serialized schema. DDI in social sciences, it talks about something completely different. Well, you probably can't see it, but if you have biodiversity, you will have something like kingdom, phylum, class, order, family, and you can describe the plant, which you are talking about. If you have DDI, which is for social sciences, you will have better information about the studies, the questionnaires, the people, or how the study was conducted, and so on. So these schemas can help you to describe your kind of data. But of course, it doesn't fit to everybody. Other thing that was mentioned there is personal identifiers. That's generally string that identifies something. I hope somebody will correct me or explain it better in the like today later. But I think we can go with this for the moment. You have different identifiers. Of course, we have DOIs for publications. Everybody knows them. We have DOIs for other stuff, such as data. What people maybe don't know that related metadata for publications and for data are different because it's from different agencies. One is Crossref. It's working with publishers. Data side is for data repositories. So not all DOIs are created equal, especially regarding metadata that they contain, but you have also different technical things like handle or URN or ARC, and URN again, oh, that's an error. Or you can identify some organizations with ROR, people with ORCID, and so on. And many more things, and maybe I should edit more dots, because there are many things you can, like the persistent identifiers can exist for kind of unlimited number of things. The problem is that they have to be persistent, so they won't disappear. So which is kind of tricky to do. They also need to be unique. One identifier doesn't lead to two different things. And they need to be resolvable to some extent. If you know the identifier, you should be able, using some service, get some more information about it or its representation. These things are very nice, they are very useful, and they are good for referencing things on the web generally. Again, we have example from Zenodo. We have another example from ČSDA. We have something with ARC from another system. Another thing is handle, which you can use in DSpace, for example, and the last one is another DOI from Figshare. So there are different things. One funny thing that you can notice is that this is used as a link. This one has this small icon here because you can copy it easily, because you need to work with these things and you need to create some relations. It's important as well for the ecosystem, because if you say this piece of data is related to is related to this publication, for example, as in this case, and there is some software that was working with it, or 2 pieces of software. If you put it into the repository, there may be some discovery systems, for example, as in this case is a data site commons that will create for you some visualization. It will make able to for users to check like the relation between the objects they created and put on the internet. It's a very nice webby thing. So who does what? Repo builders should set up metadata schemas and like think about what they want to describe in their repository, how people will search for things, and how will they organize the data using metadata in the repository. They should set up some PID schemes and enable linking between different types of context, and they should also propagate the data to other services. So if you have metadata, you don't want to have them searchable just through your own system, but you want to have it searchable elsewhere. For example, NMA, which does it through a specific metadata format, or OpenAir, or Google, or whatever. You need to get the metadata out of your system in some understandable format. Well, users have to use it properly. They should use rich metadata, which is part of the FAIR principle, but it's really on them how much they describe their objects, and they should use the PID linking. Again, many repositories have it as option, but people should really use it. Okay, we will then solve metadata and PIDs. What about the access? Should the data be accessed openly, or should there be some restricted access? Of course, open data were buzzword a few years ago. Now it's more about fair data with this rule as open as possible, as close as necessary, which is quite reasonable. But there are still some repositories that allow only open access data. And in some fields, it's really the standard that everything is open, which makes things very easy and simple and nice. There are also some data that needs some special care, something with restricted access and embargoes. That wasn't a few years ago. It wasn't possible to do this in Zenodo also, but now like times change. There are some data need very special care, I would say, which is sensitive data, which is, from my own perspective, I'm not sure how much they should be in like public repositories, or if they should be handled in a different way. But there is a specific working group as part of the project, and they will help you with sensitive data, with more specific questions. One of the things that you should be able to do if you find a data set on the internet somewhere, you should be able to find information how or if it's possible to get access. Again, it can be done in different ways. In Zenodo, you have just download button, which is very simple, but you can also have this embargoed access. You can have some way of presenting the content to the viewer. For example, this one is the part with Křižík funeral, especially this guy is holding kropenka here. You don't see it, but it's really there as it's described in the metadata. Or you can have some information, at least from the data is not yet ready to be shared. It will be some revisions. We will see if we will share it later. For repo builders, it means they should decide if limited access will be possible, if they want to have to work with all these things. Then they will have to set up some groups or communities, use access and control. AI may be very useful for these things. For users, well, the options depend really on the repository. For users, they should be able to decide what should be published and when. Data formats are another part. Should they be there should be open, but maybe sometimes it's necessary to do something in proprietary format. The main thing is to think about long-term preservation and the question if I will be able to open this thing a few years from now. People also should think about if there are any open alternatives, and if not, or if not. Generally, it's also useful to provide some information about software. And use domain standard when possible, because then it's a bit higher probability that something specific that can work with the data already exists. For this case, I took MBDB, which is one of the project repositories. Like, I don't understand any of it, but I expect this is some kind of domain standard, so anybody coming from this domain would understand that ITC means this kind of data. They are openly available, you can work with it. So this is example how we can do formats in a very nice way. For repo builders, again, this means that you should expect different data formats, and you should really think what kind of data you will get. You can, for example, implement weavers if you will know that you will work with image data. Perhaps you can limit accepted formats as well if you are really confident about it and want to limit all the options. Users, on the other hand, should prepare the data in open formats if possible, and decide what format will be stored in the repository. Licensing is, I guess, almost the last one. It's important because you need to know what can be done with the data. Creative Commons are most common, but they don't fit to everything. It's important here to understand that not everything that's on the internet is free. It's free for use, because if you don't put any license to something that can be considered author's work, then copyright applies, and its reuse of the data is limited or protected by the copyright law. So it's really important for somebody depositing the data to describe what can be done with the data. We have, again, standard example with Zenodo, with Creative Commons 4.0, easy. Another one is from the Riot. I mentioned it at Access. They allow just data that go under public domain, which actually doesn't work in Europe, but never mind, which is CC0. Everything is free there. This one case is funny because it's embargoed, but it's under CC0. So it will be opened, completely open, but not yet. And last example is academic specific license that is used in Lindat Claria. And it actually is an agreement that's with Faculty of Informatics, Botanická 68 Brno, who have their own license and want users to sign it and do something about it. So if you need something like signing of licenses, you need some framework for it, and it may be complicated. This is something that was specifically created for Lindat Claria. What does it mean for repo builders? They should think about proper licenses to be used, enable users to select them, and think if something more advanced than CC, for example, is necessary. And users need to understand what they do, what they want to allow to do with data, and select proper license when they deposit them. Documentation is actually the last one. Oh, I see. Documentation is part of reusability. People should be able to understand what data are they looking at. It may be done in different ways. Some of the information about the research data can be provided via metadata fields or cookbooks or methodology description. Something can be put into metadata as well. And it should be possible to trace provenance information. This is an example of a simply README file that was for some study. It's from Lindat Claria again. There is something in the description which will tell you some details, but not all of them. And in the README file that's part of the data set, it's described in more detail. So you know how the data were created and what you can do with it. I just got a jump scare when I saw you. So I understand, but I guess this is almost the last before, just 2 slides. So it's last one, I promise. Repo builders should prepare metadata schemas for domain-specific cases when they need to put some more documentation into metadata, or allow to provide documentation in some other form. And users should keep the data documented, which is tricky and can take some work, and they should do it in a way that they think about other user needs. At least provide some README files is good practice in it. So conclusions from my perspective is that FAIR is really shared responsibility. It needs to be supported by the repositories, and you should understand your use case. But the principles also need to be applied by the repository users, which you can't really influence so much as a repository owner. But what you should do as repo builders, you should try to create the right environment for your use case, because there is no one-size-fits-all solution. Thank you very much for not killing me, that's all.